Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, as we know, matter is made of atom and all atoms have a basic structure. During past 200 years, scientists have proposed different models and theories as the atomic theory grew as a series of models that developed from the experimental evidence. As more and more evidence were collected, the theory and model were revised. So let's start with a new topic with the introduction of atomic theories of matter. But friends, before starting with the atomic theories, we should understand what are the fundamental laws of chemistry. As all the matter can be broken down into elements, right? But is matter continuously divisible into even smaller and smaller pieces? Or is there any ultimate limit? Although most of the thinkers, including Plato and Aristotle, believed that the matter is a continuous in breakdown. But the Greek philosopher Democritus disagreed. According to him, elements are composed by very tiny particles called atoms. So now, before going to the deep discussion, let's first understand the most important fundamental laws of chemistry, which helps us to understand and correlate the theories well. So what are the fundamental laws of chemistry? First is the law of conservation of mass. Second, law of constant proportion. Third is the law of multiple proportion. So by one, let's discuss and understand what are these laws. So let's write down law of conservation of mass. Who proposed this? Scientist Antoine Lavoisier proposed this law. What does the law says? What it states? It states mass of the reactant is equal to mass of product. Let's take an example and understand the law. For example, we have 5 different kind of the flowers we have. Right? And plus we have one flower pot. Now what we have the product, let's keep this the mass of reactant. These are the reactant with 1 gram, 1 gram, and let be it 50 grams, right? So here, what will be the product of this? We'll be having a beautiful flower pot. What will be the mass of here? It will be 55 grams. So what we understand here, we understood that mass of the reactant, the total mass of the reactant will be always equal to the mass of the product, as mass is neither created nor destroyed in chemical reaction. In other words, we can also discuss with the definition that the total mass of the substance present after a chemical reaction is the same as the total mass of substance before the reaction. I hope you have understand now what is the conservation of mass. Now let's understand by this. So, who discovered? Sir Anthony Levison in 1789. He discovered this law of conservation of mass, which says that the total mass of the substance present after a chemical reaction is same as total mass of the substance before the reaction. That is, mass of a reactant is always equal to the mass of product. Here you can take one more example. There's a toy plane with the reactant side. We can see so many parts, and after equal there's a one beautiful toy plane, aeroplane you can say. There's no extra part has been put into this plane. That is, the mass of the reactant is equal to the mass of product. You can also see this funny cartoon where 1990s is a before and 2008 is after. You can say the where the mass is actually changing. It is funny, yes, but it's a sensible kind of picture which can make you understand the law of conservation of mass. Now let's understand by the chemistry point of view. We have here a chemical reaction of silver nitrate plus sodium chloride, which gives us silver chloride and sodium nitrate. Here you can see the mass of the reactant, the silver nitrate and sodium chloride, that is 300.23 grams, is equal to the mass of product, which is also, you can see, the same mass of silver chloride plus sodium nitrate. Here is the distribution of the reactant atom of the reactants, and here the atom of the products. Now I hope you have a bit of understanding of law of conservation of mass. Now let's come up to the second, which is the law of constant proportion. Let's understand by the rough. What is law of conservation of proportion? That is a constant proportion. See, it is a law of constant proportion, right? Who proposed this law? He is a great scientist, yeah, Frost. In 1799, he proposed this law. This law is also called Frost law or definite proportion law, right? What does it say? It says that all the samples of a compound have the same composition. That is, the same proportion by mass of the constituent elements. Now let's take an example and understand this clearly. Okay, I'll give you two examples. First, very common example. Let's take 6 glasses. Like this. Now get a fresh water. One I have taken from pond, one from lake, one from river, one from my bathroom tap. This I took from my AquaGuard purifier. And this I take randomly from one of the taps in street. The water. Now, second step, what will I do? I will check the composition of all the water, that is all the glass of water. What will I find? This is A, B, C, D, E, F. I will find A, B, C, D, E, F, all the glasses from different sources I have collected the water from, have the same composition. That is, each glass of water having the same composition, that is H2O. That is, two hydrogens are combined to oxygen to form water. By this I hope you have understand. Now let's take up this next example which will make you more clear. Let's make a meeting or you can say let's celebrate a party with the guest. He's in from village. This guy came from USA. This guy has come from India. This is from Dubai. This man is from China. This man is from UK. This man is from Thailand. This is from Sri Lanka. Okay, I have these guests. Now what will you see? Each and every guest having two eyes, one nose, two ears, one stomach, one heart, two lungs, two kidneys, two legs. Yes, that is. The conclusion is, here I can write, the conclusion is all the human beings have the same composition. That is a physical composition, right? From where they have come doesn't matter. the composition of each and every human being, the person having the same composition. Now I hope you have understand the constant proportion. Now let's explain in the other way. That is, who discovered this? George Proust. In 1820, he discovered this law which says all the samples of compound have the same composition, that is the same proportion by mass of the constituent element. What does this mean? That the relative amount of each element in a particular compound is always the same, regardless of the source of the compound, as I have told you the water example and the meeting of the human beings from the different countries. Right? We can take an example, the pictorial example. There are three kinds of sofa, but the material is the same. The composition of the three of these sofas are same. That is, they contain wood, cloth, nail. The composition is same, though they are looking different, but the composition, the materialistic part, the raw materials are the same. We have just seen this example. That is, from each and every different source we can get the water, but the water have the same composition, that two hydrogen attached with the 1 mole of 1 atom of oxygen containing 18 grams per mole of water. Right? Now let's come up to the multiple proportion. So what is multiple proportion? Multiple proportion. By multiple, what do you understand by the multiple? Multiple means many. Proportion means the weighted, right? So, who gave this law? Scientist John Dalton gave this theory, or you can say the law, which says that if two elements form more than a single compound, the masses of one element combined with a fixed mass of second are in the ratio of small whole number. Let's take an example and understand this law. So take an example. I take example of milk plus water. These are the two, let's suppose these are the two elements or two substances which makes two things. It makes tea, it coffee. If I keep this proportion fixed, and I keep changing this proportion, what will I get? Two products. One with the higher water, one with the lower water. So what will the proportion? The proportion will be 2:1. That is a minimum whole number ratio, right? Or you can also take the example of carbon and oxygen. Here, carbon oxygen also forms CO2. It also forms carbon monoxide. That is carbon dioxide. This is carbon monoxide. Right? So what will be the ratio? That will be 2:1 of the ratio. As the second substance or second element goes on increasing, the whole number or the ratio of the particular reaction will be changing accordingly, right? So let's explain who discovered this. Sir John Dalton discovered in 1820. He said that if two elements form more than a single compound, the mass of one element combined with the fixed mass of the second are in the ratio of small whole number, that is the same element to combine in different ratio to give different substances. You can see here, as I've told you, just gave you this example, that is carbon. First, carbon is combining with two atoms of oxygen giving carbon dioxide, and in second, carbon, one atom of carbon is combining with one atom of oxygen giving carbon monoxide. Here are the calculative and ratio part. See, here the mass of the carbon monoxide and carbon dioxide. What is the carbon and the carbon oxide? It's 16 of the mass of the oxygen, here 32. That is the ratio of carbon dioxide to carbon mono, that is the oxygen ratio. The element ratio is 2:1, right? So let's come to the evolution. We have understood the laws of the chemistry, that is the fundamental laws of chemistry. Now we have to understand the series of theories and inventions which have been throughout in the atom timeline. So who first gave the structure of atom theory is a Democritus. In 460 he gave this law. Let's write down one by one. That is Sir Democritus in 460 BC. He gave this law. He said, he's a philosopher, he said that the word atom came from the Greek word atmos, which means indivisible. He gave the idea that the matter is made of an atom. That is, he called the matter is made of an atom. Second, after he gave this philosophy, then Sir Dalton in 1803 AD, based on the laws and experiment, Dalton developed a theory of matter with the four main concepts. First, he gave the concept that all matter composed of tiny particle, that is atom. Second, he also said that atom of each element are exactly same, that's alike, and have same mass. Thirdly, he also says that an atom of one element cannot be changed into atom of different element. With the fourth and main postulate he gave, that the atom of different elements can join to form compounds. After he gives his postulates, then Thomson, the scientist, in 1897, he gave the discovery of atom, which says atom is not a simple solid sphere. He said that an atom contains subatomic particles, very very small particles, negatively charged. We call it electron, proton, the positive one, neutron, the neutral charged particle. He proposed the model of chocolate chip in cookies like model. After this, Sir Rutherford in 1912, he is the scientist who knew that there is a positively charged atom came from the subatomic particles called proton. He gave rise to the proton discovery, in which he begins to test the theory. His model describes an atom as mostly empty sphere with a continuous nucleus that contain nearly all the mass of the atom. I hope you are following the series. After his discovery, Bohr in 1913 modified the Rutherford model and gave his model called Bohr's model, in which he proposed that each electron is a certain amount, having a certain amount of energy. amount of energy which rotates around nucleus with certain energy with it. And he also proposed that the electron moves around like a layer of onion. He called it planetary model. After he gave this planetary model in 1913, now what we follow is we follow this modern concept of that we follow now is a modern quantum theory. We call it cloud model. This is a post 1930. We accept this model today as we say that electron moves around the nucleus have with a certain energy level, and electron cloud gives atom a size and shape. So this is the series which we were following. First Democritus and Dalton, then Thomson, then Rutherford, Bohr, and now the modern quantum theory with the cloud model. After all these theories, now friends, it's time for your activity to give me the answers. Just see this picture and can you suggest or can you guess which law is this and what will be the product? Let's do it in 5 minutes. It's very easy now. Now thanks friend. I hope you have understood this session of laws of chemistry and the series which we saw just right now, the atom theories and models. In next session we'll be studying Dalton atomic theory, which is very important, the base of the atomic theories, and the application to this law by the Dalton atomic theory. Also we'll be discussing bit of modern atomic theory also. Thanks for attending this session. Thank you guys.